Uh, Good afternoon, fellow Foundrymen. This is Sendil Kumar from IIF Chennai chapter. Before we start things, as usual, please put yourself on mute, and you can unmute yourself on end of the program and raise your queries. The speaker will be able to answer all your queries. And it gives me immense pleasure to interact with you for yet another webinar. And we have our speaker today, Mr. Ajay Kumar sir, is a well-known personality. Even though he's from the institute side, I think he's gelled with IIF for a very long time. And it's great honor to you be here, sir. And also congratulations for your award for recent IFC for Applied Research and Innovative Technology Award for Chandraman Award. And thanks for accepting invitation, sir. To get things started, now I request our chapter chairman, Mr. V.K. Ramans, to welcome the gathering in formal manner, please.
Yeah, thank you, Sendil. Again, welcome, Dr. Ajay. Dr. Ajay is not the unknown face for IIF. He is a very well-known face for IIF. So his contribution to IIF are very huge and very useful contribution he made in his for the last 2 or 3 years. So today's topic is going to talk about the latest development in cast metal matrix composites and future opportunities in India. So this is the very needed topic. So on behalf of IIF Chennai chapter, I welcome all the members, all the fellow Foundrymen, also Dr. Ajay for this wonderful program. Definitely Ajay's knowledge will be helpful for all of us, and definitely it will enrich our knowledge further. So as our secretary told, you can raise your question at the end of the program. So Dr. Ajay will be in a position to give full clarification and the answers for all the questions raised by you. Once again, welcome you all. Once again, welcome, Doctor. Thank you. Over to Sendil now. Thank you.
Thank you, sir. See, I normally say that when we talk about any subject, we need to know from whom we are listening. And as we all know, Ajay sir very well, but still as a formality, we need to introduce to the gathering. Now I request our Joint Secretary, Chapter Joint Secretary, Mr. Rajmohan Madhyalikan, to introduce the speaker to the audience, please.
Thank you, Mr. Singh. Yeah. Thank you, Mr. Singh.
Yeah, please.
Welcome, welcome, Dr. Ajay Kumar. Mr. Ajay Kumar is an Assistant Professor of Mechanical Engineering at Indian Institute of Technology, IIT Tirupati. Dr. Ajay Kumar research interest encompass material design, mechanical behavior of advanced materials at bulk and small length scales, including composite materials, lead-free solder alloys, composite foams, shape memory materials, and metallic coatings. He also works in tribiology and addresses problems related to friction, wear, and lubrication of materials. He has published several papers in peer-reviewed journals and book chapters. He holds 4 patents. His group is engaged actually in various aspects of material processing, properties, and characterization. Research programs in his group aim at constructing a quantitative and predictive understanding of the phenomena underlying the material development for industrial applications. His group employs a variety of experimental and computational tools to establish process structure, property relations in materials. He holds a PhD, Department of Mechanical Engineering from IIC, Bangalore. Before that, actually, he finished his master's in mechanical engineering from Maulana Azad National Institute of Technology, Bhopal, and holds a mechanical engineering bachelor degree from Madhav Institute of Technology and Science, Gwalior. Prior to IIT Tirupati, he was a research associate in Department of Mechanical Engineering at IIC and postdoctoral research associate in School of Mechanical and Material Engineering, Washington State University, USA, and postdoctoral research associate in Department of Material Science and Engineering, University of Wisconsin, USA. So he has published actually several articles. He has 25 international journal papers, 40 national and international conferences. And as I said earlier, he has 5 book chapters and 4 patents. As our secretary said, he recently won this Chandran Menon Memorial Award under that Applied Research and Technology in the last IIF held at Bangalore. Over to you, sir. Thank you.
Okay, so thank you so much. Let me start today's talk with acknowledgement to my professors and my students who contributed in my journey for working in the area of metal matrix composites. I also thank IIF. My association with IIF been almost more than 4 years now, and we are working together in various platforms. And so I am very much thankful for IIF and IIF Chennai chapter. So shall I start, sir? If there is no.
Yes, sir. Yes, sir. You can start, sir.
Thank you. So today I will be talking on latest developments in cast metal matrix composites and future opportunities in India. So the outline of my talk will cover the short introduction about the MMCs, as you all will be aware about the MMC material, and discovery of first cast MMC, what is the global market and recent trends in MMC. And then I will also discuss little bit fundamentals about the effect of microstructure and reinforcements in developing the MMCs. And then what is the performance and property of these MMCs, and where we can implement the MMCs in various applications, and some of the developments which we are doing in IIT Tirupati. And then I will also discuss what are the research imperatives for future developments, and then I will summarize my talk. So the discovery of first cast MMC metal matrix composites happened in 1969, where Professor Pradeep Rohadgi, whom I worked with for almost 3 years, he developed the dispersion of graphite particles in the aluminum metal matrix through the injection of the injection in the melt. And this process he developed at MIT USA. So you can see here he has used the very simple setup for mixing the aluminium and reinforced with the graphite reinforcements. And then he has got very beautiful microstructure. You can see the graphite particles embedded in the aluminium alloy. So this was the first time happened when Professor Pradeep Rohadgi and Professor Wadia in MIT USA, they developed this material, this process. And since then the journey started, and then this MMC field has progressed a lot, and a lot of people started working on developing the different metal matrix composites for various applications. You can see the global market from since, so this is the figure I got from the literature. You can see here from since 2012 to 2019, you can see the market also is increasing. Number of research papers are also increasing in the area of metal matrix composites, and then for the several applications. So you can see here aluminum based composites for different applications are being used in different applications in industries. When we see the global market of the composite materials, most of us are aware of the composite materials of various categories. Here I am talking about the metal matrix composites. So you can see here India is also one of the leader in the area of developing the metal matrix composites. Several institutions in India, especially CSIR labs like CSIR Trivandrum, CSIR Bhopal, and several IITs faculties also started working in this area, and now they have developed a lot of components using the metal matrix composites. Now, why metal matrix composites? That also we need to understand, because it has high strength to weight ratio. very high thermal stability, low coefficient of thermal expansion, and high wear resistance. Because of these features, we are interested to develop these metal matrix composites for various applications. Including this, we also need to understand what are the controlling parameters when we develop these metal matrix composites. So when we develop the metal matrix composites, we have two different phases. We have the metallic material as a matrix material, and then we have the secondary phase that can be a polymer, that can be ceramic phase, that works as a reinforcement in the metal matrix. So based on the reinforcement and based on the matrix, we name those, we name the composite materials. If it is fiber as a reinforcement, we say it is a fiber reinforced composite. If it is a particle as a reinforcement, we say it is a particle reinforced composites. And if matrix material is as a metal, then we say it is a metal matrix composite. If it is ceramic, then we say it is ceramic matrix composites. So that is how we name the material. And then what are the controlling parameters that also decides the properties of materials. So we have the disperse rate of different size, shape, content, and distribution. These are the four parameters which will play a very important role in MMCs.
Participants, please mute yourself.
Provide. And then dispersoid matrix interface bonding. When we talk about the metal matrix composites, we have two phases. One is matrix phase and there is the reinforcement phase. So the bonding between the matrix and the reinforcement phase becomes very important. And then the microstructure, and then it relates to the properties. Now, what are the challenges we are going to face? We are going to face the following challenges. First is the reproducibility. Second is the uniform distribution of the fine second phase particles that will be as the reinforcement phase, and the interface between the matrix and the reinforcement. So these are the challenges which all researchers or whoever is working in this area, they have to understand, they have to address these challenges while manufacturing the metal matrix composites. Now here I am trying to focus my talk on particulate reinforced MMCs, where particle will be as a reinforcement, and then aluminium, magnesium, and copper will be as a matrix materials, because they are very easy to fabrication, low cost, and then they also give the isotropic properties. Now, as I mentioned, their journey started in 1969. Since then, you can see here continuous fiber composites also being used in Space Shuttle and Hubble Space Telescope. After that, particle reinforced composites being developed, where people have used SiC whiskers, SiC particles, and then they have used these materials in electronic racks, cross beams, and ultrasonic inspections. Then also some of the new reinforcements where alumina and other composites also being used. And then they have used these materials in helicopter bearing liners, and they have also used nanoparticle of different ceramic materials as reinforcement. So when I talk about the metal matrix composites, I have mentioned that we have different categories of MMCs based on the reinforcement phase and the matrix phase, and then different size of reinforcements varying from 1 mm to 500 nanometer. And what is the volume fraction of these second phase materials in the metal matrix or any matrix materials, and what are the different properties they can attribute to the composites. Okay, so this is how different types of metal matrix composites are there. So this is the different microstructures. You can clearly see the different classification based on the different size, arrangement, and the shape of the reinforcement. And they are the actual microstructures of aluminum silicon alloy and ductile cast iron. So you can see here you have the different type of needle shape reinforcement. Then you have the different irregular shape of particles depending on the size and arrangement and shape of the reinforcement. We can decide the properties of the materials. So the reinforcement particles can be in the form of sphere, they can be in the form of fiber, and then we can also have the laminates. Okay, this is how we decide the different categories of metal matrix composites. So these are the real pictures, real microstructures where we have seen aluminum silicon alloy reinforced with sapphire fiber, and then aluminum alloy with SiC reinforcement of different volume percentage. So you can see here the size of the reinforcement also is varying, and the volume percent also is varying. And then this is the microstructure for aluminum graphite composites. So these composite materials can be used for travelological applications where you need less friction and more wear resistance. Now, when we understand the metal matrix composites and different type of the composites, what are the reinforcement phase and the matrix phase. Now we need to know what are the different type of manufacturing process we can use to develop these MMCs. So we have three different type of process. One is the vapor deposition, where chemical vapor deposition and physical vapor deposition. They are the different manufacturing process we can use, and each process is having their pros and cons. But these processes are very expensive and also limitation in size and shape. Then we have the liquid state processing, wherever all casting process comes under this category. So casting process, as you know, that it is the cheapest and the mostly used by all the industries, easy to use in industry, but there are some challenges, undesirable reactions we cannot avoid, and then the large quantity of reinforcement also is a problem when we reinforce or when we embed large quantity of reinforcement in the metal matrix. So I will show you some of these slides how to address these problems. And then the third one is the solid state processing, where the powder metallurgy is one of the route, and another solid state processing which is now recent trend is the additive manufacturing, where the friction ester additive manufacturing is being used or modified or modular technique to develop these MMCs. Now, most of you are aware what are the different type of strengthening mechanisms. So all of you will be from the metallurgical or materials background. So we have different type of strengthening mechanisms, how we can strengthen the material. Uh, so we use the different type of strengthening mechanisms. So first strengthening mechanism is the grain refinement strengthening, where we try to refine the grain size of the matrix material. And here we use the Hall patch equation. Then we have the Orobon strengthening. So you can see a dislocation loops. So dislocation density increases, and then they also contribute to increase the strength of the material and the coefficient of thermal expansion mismatch and the load transfer. So there are different uh, strengthening mechanisms from the fundamental perspective we use or implement in explaining the metal matrix composites strengthenings. Now, as I mentioned that we have several advantages of developing these MMCs. First advantage is we can use these MMCs at room at and high temperature, high stiffness. They also have the excellent strength to density and stiffness to density values, improved fatigue resistance and improved creep resistance. So fatigue and creep is very important property for high temperature applications, as well as where we have the cyclic loading. So this also we need to understand. So here basically the bonding between the matrix and the reinforcement, as well as the size of the reinforcement, will play a very important role when we talk about the fatigue and creep properties for MMCs for different applications, and obviously isotropic properties, because we are talking about the uniform dispersion of the second phase particles, and then it can be riveted, brazed, welded, and plated. So there are different uh, advantages we have for the MMCs. Now let us understand the cost also. So when we talk about the cost, as I mentioned that we have different type of the reinforcement phases. So we are using the particulate phase, which is going to be the low cost. If we use the continuous fiber whiskers, again it will add some cost, and fibers it will also add some cost. And then the diffusion bonding and the powder metallurgy and liquid metal. So there are three different routes or concepts we are going to use. So now we have to understand the cost when we use the particulate as a reinforcement and liquid metal is a processing route. The cost is going to be very low and it is going to be economical process. That is why I am talking about the cast metal matrix composites, where we can provide the isotropic properties to the material, and then we are going to use the casting process as a manufacturing process, which is acceptable by most of the industries, as well as it is also the economical process. Now let us discuss about some fundamentals when we use the casting process, when we melt the material and solidify the material. So we have the microstructure where we have the grain boundaries, and then we are using the second phase particles. So either these second phase particles will be sitting on the grain boundaries, or they will be inside the grains. So intra granular or intergranular, these two type of things may happen depending on the manufacturing process. If we are able to refine the grains during this manufacturing process, then we can, the strength of the MMC also will increase, and you can also see the grain size also we can control in various ways. So we can use the grain boundary strengthening mechanism and oro bond strengthening mechanism to explain the MMC strengthening. And then we can also use the nanoparticles. So when we use the different type of particles, we embed the particles in the matrix because of we face a lot of challenges during the mixing. So these particles generally agglomerate during the mixing. So we have to carefully understand how we can mix these particles, because they are going to have the very high energy interface surface area. So we have to control the distribution carefully, and so that no we can get the uniform dispersion when we use the micro size particles or nano size particles. Now we are talking about the manufacturing process of the MMCs. So here I am introducing the in situ MMC process. So there can be ex situ process also, but in situ process if we can use, where we can control the parameters, control the properties during the process itself, that will provide the good properties for the MMCs. So we have different categories here. One is the reactive, and there is pyrolysis and the morphology. So we have the different type of interfaces during this in situ metal matrix composites, gas liquid interface, liquid interface, and soil liquid interface. So we have to understand these process as well. And then you can see here, this microstructure shows the well distributed particles in 30 micron size SiC in magnesium, and this we have used here the pressure infiltration process. So I'm going to show you this process. Now, what are the challenges are there, scientific issues when we make the cast MMC for different applications? First challenge is transfer of reinforcement into the melts, then movement of reinforcement in the melts, effect of reinforcement on viscosity and fluidity of melts, and hot tearing effect. Effect of reinforcement on nucleation, growth, and microsegregation in the solidifying matrix. And then when we mix the reinforcement particles, we also see engulfment or the pushing of the reinforcement by the solidifying interface, and the distribution, bonding, and volume fraction on the physical and mechanical properties of cast MMCs. So these are the scientific issues which people have already addressed some of the issues. And when we are talking about the recent trends, some of the issues are already addressed, but still some of the issues are still exist, which need to be addressed through future research. So here we are talking about the specific stiffness and the specific strength of these materials. So in this aspect also, these MMCs show very good performance. Now, as I mentioned that we can use the different type of casting process. So here I am giving a couple of examples of the casting process. So one casting process is being introduced long time back is the ester mixing. So we can use the ester casting process, where we can mix the reinforcement particles in the metal matrix. where we can use the mechanical stirrer to mixing the particles to avoid the agglomeration. We can also use the ultrasonic vibration methods to avoid the agglomeration, and then so that no these reinforcement particles can be mixed uniformly in the metal matrix. And this is the old picture where we used our regular furnaces, but now we have the modular. We have done the lot of improvement in our equipments. So now we have dedicated stir casting machines in our lab where we can control the mixing, control the process parameters, and then avoid the defects in MMC. Another process is the infiltration process. So basically, we can infiltrate the second phase particle through the liquid metal, and so it will basically provide a lot of advantage. We can control the distribution of the second phase particles, and also the defect also we can control in the infiltration process. This infiltration process we can also use for uh, several applications. So one application is MMC. Second application, we can also develop the metallic foam or composite foam, lightweight composite foam. So I will also show you some of the examples how we can use this process. So when we talk about the pressure infiltration, you can see here we have the preform material, and then we have the liquid metal. So liquid metal can we can make the preform of the and then from here the particles or particles can infiltrate through the liquid metal. So we have the liquid metal here, then we have the solid metal, when we have the uh, uninfiltrated preform. So this is how this process helps, and the particles will infiltrate through the liquid metal, and we will get the uh, fine distribution of the second phase particles in the metal matrix. Now this is the example of graphite fiber aluminum composite material, and this has been used for the Hubble Space Telescope also. And so here they have used the 6061 aluminum alloy and the graphite as a material. But the main challenge when we use the graphite material as a reinforcement, um, uh, we have to take care of the surface wettability of the graphite or the carbon material with the metal. So they use different type of treatments on these graphite materials before they reinforce in the metal matrix, so that the interface will be bonded properly, and also the distribution of the graphite particles in the matrix will be uniform. So you can see here significant improvement in the properties of aluminum matrix composites, where they have used the alumina and aluminium. Then they have also used the aluminum 319 alloy. So you can see the properties. So concentration wise also you can see how much reinforcement they have done, and the strength of the composite materials have increased significantly. So this is how it goes. You can see the tensile stress strain curve for these composite materials of different types. This is basically magnesium and yttria example. One of the challenges we will face in cast MMC is we can get the high strength, but the toughness will decrease. Okay, so that is how it goes. But I'm going to give you the examples where we can also increase the strength as well as the toughness of the composite materials. So here, this is the slides where you can see the literature work, the research work the people have reported in different combination of materials, matrix and reinforcement. So you can see here the size of the reinforcement face is varying from 0.3 to 0.6 micrometer, even 10 to 28 micrometer, and also 25 micrometer. So you can see the micrometer range. Even some of the research shows 23 nanometer also they have embedded in the metal matrix. And you can see the UTS, the ultimate tensile values, and the yield strength values also increasing, and the percentage elongation. So most of the things we will face problem with the ductility. Ductility of the cast metal matrix will decrease because the dispersion, sometimes dispersion and the interface between the matrix, and it will not be bonded properly. So that is why we face a reduced ductility problem in the cast MMC. We can get the good strength. Now we can also make the syntactic foams. So as I mentioned that pressure infiltration, we can use the fly ash stenospheres as a reinforcement. A lot of work has been reported in this area, even from India also. Some of the labs like CSIR, Trivandrum lab, CSI Ampri, and other IITs also, they have reported this type of work. They have used the fly ash as a stenosphere as a reinforcement material, and they have made the syntactic foams for various applications. They are lightweight, uh, and they have very good damping properties. And this is the example of lead fly ash composite. So they have used the hollow fly ash stenospheres. They can disperse in the matrix of lead. Another recent trend which is now going in the area of MMC is because the lot of work has been reported in the area of particle reinforcement composites, especially in the aluminum matrix, aluminum alloy, magnesium alloy, copper alloys. And now the recent trend is going in the area of self-healing and shape recovery cast metal matrix composites. So this concept will help a lot, especially in the crucial applications or even civil military vehicles applications. So if there is any crack uh, nucleates during the operation of any component, and once the crack nucleates, it propagates very fast. So we have to see if we can stop the propagation, if not 100%, at least some extent. So that is how the self-healing and self-shape recovery concept will help. So we try to reinforce the shape memory alloys or shape memory materials in the metal matrix, and we see that if any crack develops, can we heal the crack? If not 100%, at least 60 to 80%. If we are able to heal the crack, we can save a lot of lives or accidents. So that is how we conducted a very preliminary experiment where we inserted the shape memory wires, and then we introduced the cracks, and we have seen that if uh, this can be healed. So you can see here defected or cracked sample, and then over the period of time in 36 seconds it has healed a lot. Okay, so this is how we are introducing the self-healing MMCs. And this is the slides for just for your information that the literature work, it is started from 1965, where aluminum graphite composites started by Professor Rohatgi and Professor Badia. And then since then, a lot of groups from abroad and from India also have contributed a lot in this domain. So this is the literature work. If you are interested, I can provide you these informations. Now, where are the applications of these materials in the industries? So if you see here the list which I am going to provide of different manufacturers: Toyota, Honda, GM, Chrysler, Volkswagen, Duralcon, Nissan, and Hitachi, and Martin Marietta. So these are the companies where they are already using these MMCs for different applications. So you can see here these all companies are uh, belong to abroad, other countries. So in India, I see very few companies are or industries are now entering into this MMC business. But just to give you the information that already these top companies, automotive companies, they're already making the composites or components using the MMC process, and they are using the casting process. So some of the companies are using the squeeze casting infiltration. Some of the companies are using other stir casting process, casting process as well. So they are making the brake rotors, pistons, connecting rods, and cylinders. Okay, and the brake rotors of aluminum silicon carbide composites. Okay, so you can see from this slide that already there are a lot of good companies, top companies, industries are there in the MMC business. So there is a need that we can also see if some of the foundry industries may be interested to develop these composite materials in future. A lot of scope in this area. Now, what are the properties we need for different applications? Also, we have a lot of data available. If we need the high wear resistance, what are the reinforcement phase we can use, and then what are different components for basically cylinder liners, pistons, camshafts, and brake components. So we have a lot of data available nowadays to implement or use these things for different applications. So we have the different applications of discontinuously reinforced metals also. So space applications where already some of the composite materials are in Hubble Space Telescope. Automotive, if you see, some of the companies are already using these composite materials in the brake rotor, exhaust valve, block cylinder liner components, and other aero applications as well, and also thermal management. Okay. So these are some of the slides. We have also published these all work before, along with several institutions. Aerospace applications, we have these MMC materials. Automotive applications. So you can see here different applications for brake rotors, autos, motorcycles. MMC are being used in these applications. So these are the applications for MMC disc brake rotor. Here the electronics cooling plate also we can make, and also other applications. This is the components being manufactured using the aluminum silicon carbide, graphite composites. Even in India, CSIR Trivandrum lab, Dr. Rajan is there. He has done he has contributed a lot in this area, and he has developed several components using the MMC process. So these are some of the things. So now I will discuss about the work which we are doing at IIT Tirupati and some of the work we have reported. So as I mentioned that when we make the composite materials using casting process, we have casting process is being the most versatile process, and it is the acceptable process by most of the industries. We can make the various components of large scale components, but a couple of fundamental challenges which we are going to face in the cast MMC is the low toughness and the uniform dispersion of the second phase particles. So this is what here we have used the solid state processing. So we have combined liquid state route as well as the solid state process route, so that now we can get the better properties, and then also we can address all the challenges which we are facing in cast MMCs. So here we have introduced the friction based process. So where we have used the cast MMC plate, and we have done the friction stir processing on the cast MMCs to eliminate all the casting defects and get the fine distribution of the second phase particles. So here you can see here these all second phase particles in the range of 20 to 30 nanometer. So if we are able to reach to that dispersion scale, we are going to get the very good properties, and also we can also refine the grains. So if from 100 micron size of grains, we have reached to the 2 micron grains from that process. So we are combining the casting process, and so basically it is a hybrid process we can use, and we can get the very good properties where we can get the high strength as well as the high toughness of the composite material. So that is how we have to address the challenges. So individual process may not help sometime, but if we can come up with a hybrid approach, we can address a lot of challenges. So here we have developed the copper based composite materials. These results are for copper based composite materials, where we have used the polymer derived ceramics as a reinforcement. And then here is the example of the aluminum based composites, where we have reinforced with the graphene nanoplatelets, and we have also seen here. So this is the true stress to strain curve for the matrix material, and then this is the composite material. So you can see significant improvement in the properties. Now another work which we have reported, or which we are doing in the area of surface alloying composites, where we are making the surface alloy composite layers over the mild steel. This is basically for we are focusing on the water industry applications. So this is the example of the butterfly valve. We have made the surface alloyed composite coatings or layers over the base metal, and this we have done using the casting process. Simple casting process we have used. So you can see here the surface alloyed layer. So this is all developed during the manufacturing process, and this surface alloyed composite has given very good corrosion resistance data results, as well as the mechanical properties. So you can see the hardness also has increased, as well as the thickness of the surface alloyed composite layer. So here we have nickel, chromium, and other elements we have embedded. We have reinforced with the matrix material. Now, as all of you are aware that today everyone is focusing on one or the different type of additive manufacturing process. So additive manufacturing process, if you see from the fundamental perspective, it is the casting process. It is the localized casting process, uh, where you are using one heat source, and then you are using the filler material as a form of powder or the wire, okay, where you melt the material, and then you keep depositing layer by layer. So basically it is the controlled localized casting process, uh, and you can see the microstructure of the any of the additive manufacturing components. You will see the microstructure similar to the casting microstructure, lot of columnar grains, dendritic grains, and uh, other defects which we come across in the casting process, that also is there. And the surface finish also is one of the very challenging issue in the additive manufacturing process. So additive manufacturing process is the localized casting process from the fundamental perspective, where everyone is now interested to work. So here also we have done a lot of work. Now we are also proposing the and hybrid approach, how we can make the composite materials using this process. So friction ester is one of the approach. This can be used for welding, alloying, processing, cladding, and additive manufacturing. So this is the approach where we use the rotating tool which embedded inside the material. So, and then we try to do the additive manufacturing in the solid state itself. So either we can use the cast composite plates and use this process. We can also make the additive layers using this process uh, through the frictional heat. Okay, so there is no melting here. It is a direct deposition. So we can use different type of approach here. Either we can use the filler material, and then we can keep depositing using this tool will rotate, and then we keep depositing. Or you can deposit you can have the powder material on the bed, and then you use the frictional heat to develop the additive layers for making the different type of composites. Even the functionally gradient composite also we can make using this approach. So you can see here these are different type of layer by layer deposition. So here we have used the consumable tool for making these layers, and then we have shown the microstructure. And here also you can see this is the uh, electron backscattered map, where you can see the distribution of the grains and other boundaries rotations. And then this is another EBSD map, three dimensional EBSD map. So you can see all the grain distributions here. And now the latest trend in the area of structural health monitoring. Now convinced we have to now overcome or come up with the health monitoring in the material system. Okay, so now every industry is interested how we can monitor the health of the component during the process, during the operation itself. So here we are introducing a lot of structural health monitoring concepts. Also the IoT concepts, AI, ML concepts also being introduced, how we can monitor the health and address the challenges. So I also have mentioned about the structural self-healing, self-repairing materials, and then structural health monitoring is another concept which should be used in all the material system. If we can monitor the crack, we can also heal the crack, then the life of the component will increase, and that will basically uh, save lot of cost uh, in terms of lives, in terms of money, and we can contribute a lot in this area. So now recently a lot of researchers are focusing on developing these self-healing, self-repairing composite materials for various applications, and also introducing the structural health monitoring system where we can detect the damage, and we can heal the damage, and we can take the immediate action so that we can save the component life. Now I would like to give you the different research imperatives which we have also published and then and compiled uh, here. So first imperative is the prevent agglomeration and clustering of micro and nano sized reinforcement during synthesis and casting of MMCs. So this will be the issue if we don't follow the correct approach. And reducing the cost of MMC, as I mentioned, that if we can use the hybrid approach, we can reduce the cost of the MMC as well as we can address all the challenges which we face. Reducing difficulty in machining also we can address. Developing property data. Yes. So just to inform you that now a tremendous research has been done in the area of cast MMCs, but still there is a lack of database. A organized database is not available anywhere, so that has to be done. If we can take we are taking some initiatives to develop the database in our lab. So maybe in couple of years time we would like to come up with a very good database where anyone can come and use that database and use for the MMC components. Developing supplier base, so and capability to cast large number of cast MMCs. So for the foundry industries, so as I mentioned that I have also shown you one slide where top automotive companies are using the MMCs, but in India still industries are hesitate to uh, uh, use these MMCs in different uh, applications. So if any one of you are interested, we can work together in this area, and then we can use the different foundry approach for developing these MMCs for various applications. And another thing is recycling of these. Recycling also is another challenge which we have to address. And then developing the manufacturing capability and user base for smart metal matrix castings, including. So as I mentioned that this is the latest trend now going on. Uh, so uh, so even our group also is focusing on developing these smart MMCs castings where we are introducing the self-healing and self-recovery concepts, developing the ultra high performance MMCs with graphene and carbon nanotubes. So now I have shown you some of the examples that people have made the aluminum graphite composites, but again, the size of the graphite particles embedded in the matter matrix is another challenge. So here we have also uh, shown one example where we have introduced the graphene as a reinforcement, and then the properties have improved significantly. So this is another area where we should focus graphene and other carbon nanotubes and other latest reinforcements we can use for different applications. Now, different applications for long range and large scale performance, like including cylinder liners, pistons, connecting rods, and housings and rotary engine components. Improved theoretical model. So whatever theoretical model have been discussed before, either they have used the what you call is the micro size particles, very large particles, and sometimes you will see a lot of agglomeration is also happening. So whatever theoretical models have been developed, but still there is a need to establish theoretical models to establish structure, property, processing relationships in cast MMCs. Okay, and understand the formation of cast structure during the certification of castings. So this is how still there are a lot of scope in this area.
Ajay sir, you are not audible, sir.
Hello, am I audible?
Yes, sir, it's audible, sir. Audible, sir.
Okay.
Audible. No issue.
Okay. So what I would like to say is it is still a lot of scope to develop new MMCs with addressing all the challenges and come up with the hybrid approach for developing the metal matrix components for different applications by industries. So it can be foundry industries and then
Yes, sir, okay.
yeah. So here I would like to summarize the things. So we have reported this entire data in various conferences, platforms. The barriers in the growth of cast MMCs, including high cost, lack of design data, which is still a need to address. Several components, including brake rotors, calipers, heat sinks, already in the application by different companies, industries, and several casting techniques, including sand casting, investment casting, permanent mold casting, squeeze casting, centrifugal casting, have been used to cast MMCs components, and then micro composites, recent work, and then now nano composites also we are talking about, and then we are talking about the graphene and other carbon nanotube reinforced composites for different applications, and also self-healing and self-repairing MMCs. So this is how I summarize my talk, and I thank you for your kind attention, and I would like to thank again IIF for giving me this opportunity. Now I am available for your questions and address if possible.
Participants, any questions from your side? Ajay sir, there is a small request. You can share your mail ID from the chat box, sir.
Okay.
Mr. N. Gaurashankar is asked.
Okay, I am sharing my email ID. I have shared my email ID also. Somebody is having some question.
Anybody have any questions?
So if there is no question, then I think they have understood completely.
Yes, sir.
Yeah.
So I hope there is no question from audience. So I thank Dr. Ajay Kumar for giving the complete details about metal matrix composites from starting to the latest technology. So I thank all the foundry personnel to spend their valuable time and improve their knowledge. So likewise, IIF Chennai chapter is conducting the webinars every Saturdays. So we'll share that information to you through your concern. So once again, I thank all the members to participate in this. Thank you, Ajay sir. Thank you.
Thank you, sir. Thank you.